Hey everyone, welcome back to my YouTube channel Summarize TI. As part of this video, we are going to continue our journey on pandas. And in our earlier video, we talked about series as a data structure we have in pandas. But in today's video, we are going to talk about data frame as a data structure in panda. Data frame is a whole table which is collection of columns, and every column represents to series, which means data frame is nothing but a combination of series, just like an Excel sheet with rows and columns. You can consider student record table or Excel as the best example. Yep. Now here you see I have created couple of examples or as a data. So I have this Excel with me, which I have created, which we are going to consume as part of this particular video. Excel, which is having the table, or you can say data in the Excel, having student ID, name, age, gender, subject ID, marks, and we have some, not a number also here, the blank you can say. Okay, so this is the Excel which we are going to consume. And apart from this particular Excel, we are also having JSON. So we have created a JSON also for the same CSV to consume. Okay. And apart from this JSON, we have the CSV also with us for the same data. Great. Now to start our journey with the data frames. So we first method what we are going to see is to load the CSV. Okay. But before we actually start the implementation, we require pandas in our local. Okay, and to have panda as part of our local, we require to run this particular command as part of our command prompt, pip install pandas. So if I go here and hit, you can hit this in your command prompt also, or in the terminal here of Visual Studio also. So I'm already having this pandas installed in my local. Okay, and having a version of 1.17.0. And if you have installed this Panda, you might be seeing the latest version because my videos might be older when you're seeing this. So once this Pandas got installed in your local, we can go ahead and start the implementation with Pandas. And just to tell you one more thing, I have created two other videos before this one, which talks about why we require Pandas, what is the importance of Pandas, and apart from this, we saw the series. What are what is a series of the data structure in pandas, correct? And series is nothing which is a building block of data frame. Great. Now let's import pandas to consume as part of our code. So import panda-pd, and you can say data frame equals to pd. PD is having a method of read CSV, which allows us to read the CSV, and if we provide the name of that CSV as student dot CSV, we will be able to read this particular CSV. Great. Now let's print this data frame. Okay. Let me clear the console. Great. Let's execute this code, and you would see our data got printed here. Okay, so let me minimize a little bit. So you see here we got the student ID, name, age, gender, whatever we are having as part of our CSV, it got read here in our data frame, which is nothing but somewhat looks like a table. Okay, now the way we have read this particular CSV, similar to this, we have one more function. Okay, or I would say one more method which allow us to read the Excel, which is read underscore Excel. Now here you can provide the path of your Excel data.xlsx, and it will read the Excel file similar to how we read that CSV. Okay, so this is the output from Excel, the same output because we are having the same data in CSV and Excel. Great. Now After this, if we wish to read this Excel from some location, for example, I have HTTPS www dot site, some website we have .com, and then if we have student dot xlsx, we can go ahead and give that path also here, and it will allow us to read this particular Excel from this location. Great. And similar to Excel, we can read the CSV also from that site. So we just require a location from that particular location. Read Excel or read JSON or read CSV will help us to read the data. Great. Now, apart from this Excel, I have one more example where we can read the JSON also. So we saw CSV, we saw Excel. Now we have read underscore JSON also. Okay. Now for JSON, we are going to say student underscore JSON dot JSON. Okay, which is this file. Now if I go back here and execute this piece of code, you would see I'm able to read the JSON also here. Yep, great. Now, this is the way we can load our data using Pandas, and this is like the very first step we perform. Okay, so before performing any operation, we require that data to be available. Great. Now, what we can do here, now we can proceed to perform different operation as part of our Pandas. Okay, so let's go ahead and see some other methods which are available. Okay. Now, apart from this, I wish to call out one more thing. So we have SQLite 3 as a library. Okay, we can connect with that using one of the Python library, and we can read the SQL tables also directly. We can say pd dot read table. Okay, and you just provide here something like star select star from table name. So it will read the table completely. So it will print something like this only. Great. Now let's proceed. And after loading data, the next important step is to inspect data and understand what does the data look like, how many rows and columns we have, are there any missing values, what type of database is this present, any unexpected or dirty data do we have in our data set, or any duplicates are available. So this is like the second step to inspect our data. Great. Now let's start with head method to see the first few rows. So let me control it and come here to the read underscore axle. Okay. And or let's see the CSV. So read underscore CSV, and here we are providing student dot CSV. Okay. Now this is the way we are able to access. If I say df dot head, okay, then it will allow us to read the first few rows. Okay. D was missing. Let me do it again. Yep. So it is allowing us to read top 5 rows. Okay. And if you wish to read if you wish to pass the number of rows which you wish to get, we can pass that number. So if I'm passing 7, then it will read top 7 rows. Okay. Now, similar to head, we also have a tail function. Okay. And the tail function allow us to read the rows from last. Okay. So let's see that also. So tf.tail, and if I see it is reading 25, 26, 27, 28, 29. So if I go here, I am having these many rows till 31st. Okay. And it is reading from this to this. Here it is reading. Okay. From Lila till this. So it is reading the 5 rows by default. Now, similar to the head, we can also pass here number of rows. Then it will read the 10 rows from last. Great. Now, this was all about head and tail. And suppose if I wish to find out the shape of my student.csv, so for that we can say um, df dot shape, okay, and just execute this code. It will provide the shape of your table. So it is saying 30 and 10. Okay. So 30 is like the number of rows you are having, and 10 is the number of columns. Great. Now, if you wish to get the data type of this particular data frame, so we can simply say df dot dtypes. Okay. And it will provide us the data type of each and every column. So you see for student ID, it is saying object, and for age, because everything is in number, that's where it is saying int 64, and gender object class is int 64. So if I go back, I see here the class is this, which is coming as int 64. Great, all numbers. Great. And the overall data type, as we know, our rows and columns are combination of int, float, and object. That's where the final data type of our table is object. Great. Now, after this, we have describe method also. So describe method provides statistical summary of the data frame. So for example, I have this data frame and I wish to find out the mean or other things. We can say df dot describe. Okay. Now, if I say this and execute this piece of code, you would see it is providing this data. So it is saying the count, the row count is 30, for class is 30, marks 30, okay, and the mean of this is this, okay, and the standard deviation is this. So here it considered the columns which are integer, okay, and if you see, we don't see anything related to the name because that is the object type. Great. So in one shot, we can get the mean, standard deviation, minimum 25% of this particular data, 50%. So all that data we can get it. We got the maximum also, minimum also. Yep, so describe will describe the table statistically, our data frame. Great. So for the age, I'm saying in the second row as NaN, okay, not a number. And I'm just going to keep only 10 rows. I'm going to remove rest of the rows. Now, if I go ahead and clear my console and actually execute this code, you would see my age here is NaN, not a number. Okay. Now I can find out the sum of any row which shows these many nulls I'm having. Okay. So if I say df dot is null, okay, and dot is, let's see, first is null. If I execute this code, it will see true for this particular age because this is null. Now, if I go back here and I make some more NaN, let's copy this here, here, and here. For the marks also, let's do it. I'm not sure why it is not selecting. Great. Now, if I go again here and execute this piece of code, you would see multiple true here. Okay. Now, as soon as we see dot is null, dot sum. Okay. And if you execute this code, you would see it will return the count of the nulls we are having in each and every column. See, so in name we don't have any null. In age we have two. In marks we have one. Attendance we have one, and city we have two. That's what we changed. So this will check for missing values and it will return row numbers, missing values. Correct? Great. Now, if suppose I have these many columns in my CSV, correct? We saw like 10 columns we have, but I just wish to access the name column. Okay. So if I say df and let's remove everything, and here if I pass name, I will be able to access the items from name column. So it will be running on the names. Okay. Now if I wish to have one more, we can say name, comma, age. So it will allow us to get the two columns. So give me a minute. Let me apply one more bracket here. Okay. Now if I say this, it is returning me name and age columns. Great. Now, if you see, we have duplicates here in age 15, 16, 15, 16, and NAN. So if I wish to find out the unique, okay, what I can do here is I can say age, okay, and after age I can simply say dot unique, okay, and if we execute this piece of code, it will return the unique elements we have in this particular column of age, which is 15, 16, and NAN. Great. Now, suppose if I wish to find out the count of the unique element, then what we can do here is we can say df age, and in place of unique, you can say value counts. So we have 15, 1, 2, 3, 3 times, and 16 we have 4 times, and NAN we have 2 times. So it will return that. So it would say, give me a minute, value count bracket. Sorry, I forgot the bracket. So if I re-execute this, you see it is giving 16 4 times, 15 3 times, name of the property is count, and data type is int 64. Okay, great. Now, if we proceed further, okay, and suppose if I wish to drop NA, so whichever row I am having here, so I am having here like multiple rows, and whichever row I am having NA, I wish to remove that particular row from the data set. So for that, what we can do here is we can simply say df dot drop NA. Okay. Now whichever row is having NaN, that particular row will get drop, and it will leave only 0 to 78, which is not having NA. And let me print the rows for your information here. So if you see in first row, we don't have any NaN, but second we have, fourth student we have, okay, and then fifth we have. So second we don't see here, okay. Second student as 002 we don't see, at 004 we don't see, at 005 we don't see, and as 006 also we have NaN here. So it will remove all the rows if any column of that row is having, or any cell is having NaN. Great. But suppose I have a column. Okay, so let me create an example here and say S10, and let's make every cell here NaN. Okay, great. Now if I go back here and print this particular CSV, we are seeing everything is NA. Now, if I wish to drop only that row which is having NA for all the columns. So if suppose I wish to drop the row which is having all the cells as NA. Okay. So the complete row itself is NA. I wish to drop that particular row. So for that, we can use how equals to all. Okay, which means all items, if this is NaN, not a number, drop that row. But you see here we have S10, so it will not get dropped at current point of time. See, we are getting, but as soon as I make this NaN, you won't see this particular row in the output. See, it got removed. Okay. And just to be pointed, here we have all. If I change it to any, which means any cell, not the row, any cell is having NaN, that particular row itself will get removed. Okay. Now, because we are making the changes here, okay, and if we again try to access this data frame, okay, then we don't see this data, the changes persisted. Okay, so all the rows we are getting here. If you wish to persist that particular data, you have to say in place, okay, and you have to say true. As soon as you say in place true, then this particular df will have updated. So it will update this particular df, which means keeping this in place true will update the data frame itself. Okay, so here you are not just updating, you are just creating a duplicate data frame. Okay, and in that particular data frame, you are making those changes, but the actual data frame remains same. But using in place equal to true, you are changing, you're making changes in the existing data frame. Though I did not do the assignment here. Great. Now let's remove this and print it again. We got things back. Okay. Now I have this number. Okay. So you see this, I have NaN here. I have NaN here. Now I wish to fill this particular number. Okay. And to fill this number, we can do one thing. Okay. We can say df dot fill NA, which will allow me to fill all the NAs. And here if I say 100, okay, and if I execute this piece of code, you would see all the places where we have NaN got filled with 100. Here 100, here we have 100, here we have 100. This is also 100 and this is also 100. Okay, but this is not the correct way where we go ahead and blindly fill NA for each and every column and rows and cells. In place of that, we can do one thing. We can have logical filling. So for example, here I see in my age, I had this NaN on the second row here, and we have here, okay. And for this, we have two things. We have two things. Very first thing is forward fill, okay. First one is forward fill, and the another one is backward fill, okay. Now, how it works is if I say df age dot fill NA, okay, and provide the method, okay, method equal to f fill, okay. Now, what this f fill will do, suppose I'm going forward from 0 to 10, then we have 15 here, okay. If I have 15 here, then next NaN will have 15. Now here we have 16, the next NaN will have 16. Now here I have 16, this will have 16. So this is nothing but forward fill. But if we go with the backward fill, we have 16 here, then this will become 16. And if we have 15 here, this will become 15. So let's see that. So you see this, it was 15, it becomes 16. It was 16, the NaN become 16, forward fill. Okay. Now if we see the backward fill, it will be like 15, 16. Okay, let's see that. See, 15, 16, 16, 15 because it got backward fill. And if you see last one is NaN because we don't have anything in last, okay, to fill backward. So that's where it is, NaN it only. Great. Now, suppose I have this data frame with me, okay, and I have this these names, okay. Now I have this name Dia Patel, okay. I will copy this name and I wish to replace this name, okay. So I'm saying df dot df double code name dot replace, okay. And here I'm saying replace Dia Patel with Riya Patel, okay. RIYA, Riya Patel. If I execute this piece of code, okay, it will update that particular column. Let me print this. Give me a minute, please. So if I copy paste this here and execute this piece of code, you would see the Dia got updated to Ria. And let me print also here first. So remove this and execute. Okay. So earlier it was Dia Patel. Now we have replaced Dia with Ria. So this is how we can replace the item. Okay. Now suppose I have this age. Okay. I have this age and it is showing 15, 16 and NAN. But I want my age to get increment of 2. Okay, every cell should have increment of 2. So for that, I can say df age equals to df df age and then plus 2. If you have seen my earlier video, you would be able to relate where I'm going. So let's see the df age now. So here you can see every age got incremented by 2. So 15 becomes 17 and 16 become 18. And you know this variable, this particular operation, where we are performing the operation directly on the array without looping and apply that particular operation one by one on each and every element is nothing but the vectorization. So vectorization allow us to perform operation on an array at once. And this we saw in the NumPy videos. So we have one more method which allow us to get the duplicate value, okay, and set that value. So suppose I have one row, okay, so I have this row as 005 Arjun Reddy, okay, and I'm keeping the same thing here. So what it will do, it will remove the duplicate row, okay, and there are two things, okay. Let's see first the duplicate row, which is the duplicate row here. So we can say for that um, df and inside df we have df dot duplicated. So let's find that. So it returned this is the row which is duplicate in our data frame. There are two things uh, for the duplication. So we have this row also duplicated and we have this row also duplicated. Now which one to keep matters, okay? And how we can tell our code to which one to keep. For that, we have the attribute as keep, okay? And if you pass first here, it will keep this one and discard the next one, okay? So if I say last here, it will keep the last one and discard this first one here, okay? And this is how this duplicate work. Great. Now if we proceed further and we have some custom method and those custom method we wish to apply on data frame, how we can do that. And if you have seen my earlier video of series, you would be knowing how we did that thing there. So let's see this thing again with the data frame. So if you say my marks is greater than 90, then give a grace of 2 and add 2 there. And in place of 91, it will be 93. Okay, so we are going to do with the marks which are greater than 90. So we are saying df.marks dot apply is the method which we are going to use. And here we are going to say lambda x colon x plus 2. Okay, increase the number by 2 if x is greater than 90, else return that particular number as is. Okay, now if I print the marks here or if I print the df, then we see. So here we are getting 93, 80. Now if I go back here, it was 91, 80. So every number got increased by 2. Great. Here I'm seeing 91 93, yes, 2 increases. And here you see we have 80, which is less than 90, okay, or equal to 90. It did not get increased by 2. So whichever number which is greater than 90 got increased by 2. Great. Now, this is what we did with the out of the box, whatever we are having inbuilt or default, we can say. Now, here we can create our own method. We can say def update underscore age, okay, and pass this particular parameter. And here simply we can copy this and return here. You can say return and paste this. Now in place of passing lambda, you can pass update age. Okay. And if you execute this piece of code, okay, we are getting, oh no, this should not be the case. It should be x plus 2. Yeah, correct. Now if I go here and say, you see the same output with the custom method. Now we can write any method here. We can perform the same operation on each and every item. Okay, this is, I do understand one line of code, but you can like your complete business logic and apply that particular business logic on each and every item. Yep. Now we have one more method in our data frame which allows us to rename the column name. Okay, and for that, what we can do here is we can simply say df, okay, dot rename. Okay, and here you just pass a data method and you can say columns. Okay, now here you can say rename my marks column with the numbers. Okay, and similarly we can say comma and pass the other um, column name also there, and we can update the label. So if I execute this, you can see marks because we did not provide the value here, which is in place. Okay, as soon as you provide the value in place, true, it will get update to the df, and you will see here number. Okay, so our column label got replaced with numbers, so it got renamed actually. Great. Now we have one more method which allow us to check the memory usage. Okay, so if I say df dot info, okay, and this particular method will allow us to get the memory usage. So you see here it is saying column, so these are like column names, and every column is taking this much of, every column is having this much of count, okay, data, okay, and what type of data it is object or float, okay. So at the end of the day, below it is telling, so we have float 64 of 4, object we have 6, okay, and it is having a memory usage of 1012.0 plus bytes. So this particular method gives us the overall information around the memory usage. Okay, great. Now, as we know, we have discussed two things earlier in our series, okay, Panda series. First one was iloc and second one was lock. So this iloc earlier we used to access the value based of the index, and on the other hand, the lock allow us to access the value based on the labels. Okay, so now similar concept we have with the data frame also. So here if you see data frame, okay, and if you're saying to column 4, what it will give, it will return the data frame having rows from 2 to 4. So if you see here, it returned this. Now if I go back to my CSV, so this is 0th index, first index, this is the second index, this is the third index, fourth index. So we said here 2 to 4. 2 here included, 3 included, but 4 not included here. Okay, so this particular last item did not get included. Okay, so it will be till third index, 4 minus 1, 3. Okay, now if I say the here nothing colon 4, then nothing will by default have a 0 value. Okay, now if I execute this code, then it will be giving 1, 2, 3, 4. So index from 0 to 3. but the fourth index is not included. Now here, for example, if I say 2 colon nothing, then nothing means it will go till last row. So here if you see, it went till last row. Great. Now similar to index, we have df dot ilock method also, which allow us to fetch the values based off index. And if you see here, it provided the value second, third, and fourth index. The concept is same, but we are using the ilock method, okay, to access the items based on the index. Now suppose after this, if I wish to get the number of columns as the output, okay, I wish to have only name, age, and marks. Okay, for these rows, we can use the lock, okay, and this will allow us to access those columns. Great, let me execute this piece of code. And you see here it is giving age and marks, and it is giving the number of rows. Now, if you notice here, for lock, we have the fifth index included here. You see second, third, fourth, and fifth index, which was not there in the case of indexing. Now, let's talk about one of more concept we have in Pandas, which is sorting. There we can sort columns or rows based on the value as well as the index. And there are multiple attributes available which helps us to sort. Okay, so let's go ahead and see that. So suppose I have this data frame available and I'm saying sort this data frame based on mark column. Okay, so for that we said data frame dot sort values, and here you can pass the column name. Okay, now if you see here, it all the rows got sorted based on columns. So we see 71, 73, and then 99, and then NAN and last. But suppose if I wish to reverse the order, okay, so in the ascending equal to false, in that case, you can give this ascending attribute false, then it will be from increasing order to decreasing order. 99, 91, and then 71, and then NAN. Now, if these NAN, I wish to have this on first position. Okay, so for that we have an attribute which says NA position. Okay, and you can decide the position. If you wish to have all NAN as first, you can say first, and your NANs will get shifted at the first location. Yep. Now, if suppose you wish to have this NAN at last, you can say last, and all the NAN rows will get shifted to last. So whichever item inside this marks having NaN, all will get shifted in the last. Great. Now, after this, suppose if I take an example or the shorter data frame with us, okay, and here if I say df equal to pd dot data frame, let's create a data frame here and provide the key value pair. You say score, okay, and provide the score values 70, 80, and then 90, comma, okay, 90, and then provide the index also. For this data frame, we will provide the index here. So index equals to, let's give the labels as C, B, and then A. Okay. Now, if we print this data frame, let's see how it appears. It appears here CBA and with this score. If I wish to sort this data frame based on the index, I can simply say df dot sort index. Okay, and if I execute this piece of code, earlier you saw we have CBA, but now we said sort based on index. Now it is A, B, C. And here it is 90, 80, 70, the respective values we have. Okay, now similar to the value Here also we have an attribute which says ascending equal to false. Okay, then the order will get changed from ABC to CBA. Great. Now, after this, let's create one more data frame. So we have name as John, Sarah, David, and age is 28, 22, 35, respective ages. And then we have cities as New York, Chicago, and Houston. Great. Now, this particular data frame, if I wish to add all these values as part of the CSV, Excel, or JSON, we can go ahead and use the method. We can save these values to the respective file. But earlier you saw, correct? We read the values from the XLS file. Now we are writing the values back to these files. So for that, we have df.toCSV. Okay, and you can provide this CSV name as CSV underscore one dot CSV. Okay, and after that, just provide index equal to false. So providing that index will avoid writing row numbers. Okay, great. Now let's execute this piece of code, and you would see this particular file just got created. And if I open this file, I see this name, age, city, and everything got written here. Now, similar to this, if I update the name to JSON underscore one dot JSON, and I have to change this also, of course. So it is two underscore JSON. Okay. Now let's run. We don't have any file with the JSON underscore one dot JSON. As soon as I execute this piece of code, I see this particular file got created, and it is having the JSON of our data frame. Great. Now the last option what we have is we can create the Excel also. So here we can say to underscore Excel. Okay, and it will allow us to create the Excel. So exel dot xlsx. Okay. Now if I run this piece of code, it will create that particular Excel here. Okay, great. Now, apart from this Excel, if you wish to place your data directly inside the database, you can do this with the help of df.toSQL. Okay, so if I say df.to underscore SQL, it will allow us to write this data frame into that particular table. Okay, so you can just provide the table name here. Okay, and after providing the table name, just provide the index also if you do not wish to save that particular row indexes, and it will save the data to this particular table. And just to add the point, so you have to like create the engine or the connection with the DB. Okay, once you have that connection with the DB, you can use this particular method to save your data frame inside the SQL database tables. Great. Now, you can use one attribute also here in the to SQL, which is if underscore exists. Okay, and if you say replace, then what it will do? It will replace or overwrite each item in the table. Okay, great. Now, let's have a discussion around merge and joins we have in pandas. We can think of merge as the panda version of SQL joins. So join in pandas joins two tables side by side using their indexes. It's like matching notebook pages by name and combining information into one clean table. Okay. Now, what it does, it combines two data frames, matches rows based on column names. We have four types of joins available, which is inner join, left join, right join, and outer join. So let's see each of them with example. Now, if we talk about the joins, let's first talk about the left join. So in the left join, suppose if we have two data frames, data frame 1 and data frame 2. Okay. But in case of left join, it will take all rows from left, 100% of the rows and data from left, and matches rows from B, or if any row did not get matched, it will fill with NaN. And this matching we do based on the column. Okay. If we take an example of left join here, so we have this data frame A, correct, table A and table B. Here we have ID 1, 2, 3, 4, and names we have. Now, similarly, we have ID 3, 4, 5, 6, and we have marks. Okay. Now, if I left join this table, which means I'm going to take this 100%. Okay. Because A is in left. So I took 1, 2, 3, 4 and A, B, C, D. Now, here, if you see in table B, I have only ID 3 and 4. Okay. So for 3, 4, I have provided 60, 70. Okay. But I don't have ID 1, 2 here as part of data frame B or table B. So in this case, if the value didn't get found, we are going to provide NaN here. Now, if we talk about right join, in right join, it will take all rows from right, which is from data frame B. Okay. Now, after taking this V, it will try to match the rows from A. And again, if any row did not get matched or the data, it will fill that particular cell or the row with NaN. Okay, great. Now, if we see this right join, okay, in the right join, it will take B as 100%. Okay, so we have taken everything from the V, 3, 4, 5, 6 as ID and the marks. Now it will try to match the ID with data frame A. Okay, so in data frame A, yes, we have 3, 4. Okay, but we don't have 5, 6. So whatever got matched, it will pick that one and it will try to keep things here CD. But if any row which did not get matched or the columns or the cell, it will replace it with the NaN. So we don't have 5, 6 ID here. So that's where it replaced those names with NaN. Now, if we talk about inner join is all about whatever is matching, it will consider that. So it will consider all matching rows from both data frames. In data frame A, we have 1, 2, 3, 4 ID, and in B, we have 3, 4, 5, 6. So the matching one here is 3, 4, and here in the V is also 3, 4, which means it is going to be 3, 4, 60, 70, and CD. And yes, this is the output. So it will take whatever is common in both of them. Now, if you talk about outer join, it will take all rows from both the data frames A and B, matches the common one, other gets filled with NaN, the same thing. Let's see an example of outer join here. So we have again the ID as 1, 2, 3, 4 and 3, 4, 5, 6. It will take all the IDs. So 1, 2, 3, 4, 5, 6. Okay. Now for name, we have only ABCD for 1, 2, 3, 4. It filled. And for marks, we have 3, 4, 5, 6, and it filled those marks. Now, whatever is left, it will fill everything with NaN. And this is nothing but the outer join. Now, let's see this outer join in our Visual Studio. For that, we are going to create two different data frames. Okay, so I have ID name and ID marks, whatever we have discussed earlier. So let me create that. So we have this data frame 1, which is having ID 1, 2, 3, 4 and name ABCD. And then data frame 2 is having again ID 3, 4, 5, 6 and the marks. Okay. Now, if I have to create a join, which is a left join, for that we can use a method merge. Okay. So pd dot merge, and if you pass here data frame 1 comma data frame 2. Okay, and we are going to run this on ID. Okay, on ID column. So here I can say on equals to ID. Okay, and which join we wish to perform, left, right, outer, inner, we can provide that. So how equal to left. Okay. Okay. If I try to get the output, you would see whatever we have discussed, the output is going to be the same. Okay. So let me clear it. Now execute this code. You would see here the ID is 1234. It has taken from data frame 1 as discussed earlier. Okay. And it will take this ABCD also. Now here we have only 3, 4 matching here. So it will pick the 60, 70. Now whatever is left, it will fill it with NaN. Okay. Now if we go with the right join, okay. So what we have to do, we have to just change this value to right join. Okay. Now in the right join, it will consider this all these IDs and these numbers. Okay. And as we know, only 3, 4 is the common. It will pick the CD, and for AB, it is going to give the NaN. So you see here 3, 4, 5, 6 CD, all the numbers it got. Now 5, 6 is not available as part of data frame A. That's where it has given NaN. Great. Now let's see the inner join now. Now for the inner join, you see whatever is common, it will pick those. So where we have 3 and 4 IDs common in both the data frames. So it picked those. And for both 3 and 4, we have CD and 60, 70. So it picked those. Now let's see the outer join. So if I run the outer join, you will see here it will take everything. Now 1, 2, 3, 4, and here we have extra 5, 6. So 1, 2, 3, 4, 5, 6 test taken. A, B, C, D also came. Number 60, 70, 80, 90 came, and whatever is left, blindly make it NaN. Okay. So this is how this inner, outer, left, and right join works. So if we talk about summary, inner join is all about all matching records. And left join, if we talk about all left plus matching right. And if you talk about right, all right plus whatever is getting matching from left. And the outer one is like get all the records from both the data frames. Yep. Now let's proceed towards the join. Okay, and join is basically a shortcut for merging by index. So here we are doing a merge based on ID or the column, but how join works is it does the merging based on the index. Okay. Now, if I go ahead and remove this code and get the brand new data frames. So here I have a data frame which is having a name as a key, and I have given the index as 1, 2, 3, and here I have a score and again index 1, 2. Okay. Now, if I say join equals to df1 dot join, okay, and if I say here df2, then we can pass one more attribute as how. Okay, and you see here here we said left. Okay, now print this join. It will give you the output as ABC NaN. Why? Because we have taken everything from data frame 1, which is ABC 1, 2, 3. Okay, and here we have only 1, 2, 3 is not available. That's where it says NaN for 3. And if you go with the right, okay, then it will take everything from right, and we know like we have 1, 2 available here, so it will take AB. So there is no NaN. Great. Now similar to this, we have inner also. Whatever common, it will take those. So we have 1, 2, okay, and 1, 2 is common on both of them. So it took 1, 2 and their respective values as AB and 90, 85. Great. Now outer join is like it will consider all the rows, okay, for both the data frames. So 100% of the data will be coming here. So 1, 2, 3, okay, we have total number of unique index 1, 2, 3, and then their values is ABC. Now we don't have 3 here as an index, so that's where the third index here will get filled with NaN. Yeah. So this was all about the join. Now let's talk about concat method, which concatenates or glues data frames one on top of another based on rows, or side by side based on columns. There are two flavors of concatenation. First one allow us to stack data frame vertically one after another, and the second one is stack horizontally, which is side by side. You use this when you just want to combine data sets without matching keys, like appending months of data. Now we have two data frames, data frame 1 and data frame 2. In data frame 1, we have column A, and column A is having two rows having 1 and 2. Similar to this, we have data frame 2, column A having value as 3 and 4. Now let's see the concatenate method from Pandas. So pd dot concat, okay, and inside this method you can pass list of data frames. So data frame 1 comma data frame 2, and after this we are going to say axis equal to 0. So axis equal to 0 allow us to concatenate the data frames vertically. Okay, so result, and we will print the result and see how this will appear vertically. Great. Now let's execute this piece of code, and you can see how both the data frames got concatenate vertically. So it is 1 2, and after that we have 3 4. Now if I change this value from 0 to 1, it is going to concatenate horizontally. So here we have 0 1 2, and on the right side we have the second data frame, which is A 3 4. Now let's talk about group by operations in Pandas. So the group by function in Pandas allow you to split data into groups based on one or more columns, and then perform calculation on each group. So let's see this. Let's get one of the brand new data frame. Okay, and in this data frame, we are going to have a category and sales. Categories are getting repeated, AA, BBB, and we will apply the group by on the category so that we can group by A and B. Great. Now to group by, we are going to use group by method. So we are going to say df, okay, and here you say group by, and here you pass the property name. Okay, now here you can say sum. Great. Now let me print this. So as soon as I print this, you can see all A got grouped by. Okay, so this here, both the things. So 10 plus 20, 30. And all B got grouped by, which is 3B here. And then this is 5, 15, 25. Nothing was 45. So you can see the here group by an addition of all the sales. Great. And apart from this, if we have some more properties also, those will also get added here. Great. Now with the group by, we have aggregations also. Okay, you can apply built-in statistical functions such as sum, mean, count, max, and min, which is nothing but aggregation. Okay, so one of the aggregation we have just seen. Now apart from this, we can say mean also here. Okay, and this particular mean I can apply on sales. Let's see that. Okay, so let's execute this piece of code. Now you can see this is category, our A and B rows. And for A, we have 15 as a mean because it is considering this. So 10 plus 20, 30 and divide by 2. So it is 15. Now for B, because we have 3 and it will consider the middle one. So it is 15 as a mean. Okay, great. Now similar to this, we can find out min also here. So if you see for A, we have minimum 10 from 10 and 20, and from B we have 5, 15, 25. So here the minimum number is 5. So that's where we have 5 here. Now similar to that, we can find out max also, and max going to be 20 and 25. Great. Now for after this max, we have a count also, we have minimum also, standard deviation also. All these things we can find out using this aggregation. Great. Now call out the multiple aggregation, and multiple aggregations allow us to apply several aggregates at once. So for example, I have this sales here, okay, and here I can remove this and say dot agg, okay, and inside this we can pass sum, comma min, okay, comma max, and comma count, for example. Okay, so we have 4 here. Now, if you try to execute this piece of code, you will see for these categories, you have sum this, minimum is this, maximum is this, count is this. Okay, so this way we will be able to get the multiple aggregation. Great. Now, with aggregations, if we proceed further, we have group by transformations also. Now, transform method returns the same number of rows as the original data frame, unlike aggregations which shrink the data and rows. Great. Now, when to use transformation? When you want to add new columns based on group wise calculations, or you want to compute values for each row within its group. Okay, so each row within its group. Point to be noted. Now I will apply this transformation on sale. So let's see that. For example, df dot group by, and then here we can say category. Based on category, you can group by, and we are going to have sales here dot transform. Okay, and here we can use lambda method x colon x divide by x into sum. Okay, and then into 100. Great. Now there will be one more row get create, and that particular row data we can store in df percent. Okay. Now if I execute this piece of code and print the final data frame, you would see one more row got added. Okay. So this is for A here, and for this A we have sales as 10. Okay. And if you see the percentage, it is 33%. And for 20, it is 66%. So if you add this 20 and 10, it is 30 for A, because we are doing group by A. So if we talk about only A, we have 10, 20, 10 plus 20 is 30. And if we find out the percentage, this is 66% and this is 33%. So this is how it got calculated based on group. Now, similar to this, we have B. So for B, we have three numbers. We will add these numbers and find out the percentile. So 5 is like 11%, 15 is 33%, and 25 is 55%. Great. So this is how we can use the transform method and return the same number of rows.